Welcome back to the Python for Beginners series. This series is intended for beginners who have never encountered the language and want to learn everything from scratch. In this part, we will show how to make decisions while the program is running and how to ensure that part of the code is repeated. We will use the data objects that we showed in the last episode for this. I will show the examples in the Jupyter environment. I have also prepared several notebooks for the demonstration. I leave it up to you whether you also open Jupyter and try the examples right away, or whether you study only by watching the video. If you are going to try the examples right away, open a terminal and type the Jupyter Notebook command. So, here we go. During programming, we very often get into a situation where we have to decide which part of the program to execute, or which part of the program not to execute. For such cases, all programming languages have a mechanism called conditional execution. If the interpreter encounters such a statement, it first evaluates a condition, and if that condition is met, the code section is executed. Then the program continues to execute other commands. A simple conditional statement begins with the if keyword followed by a condition. The condition can be any Boolean expression. The condition is followed by a colon and a line break. On the next lines, there are one or several commands that are indented into one compact block. This syntax is important because the interpreter of the language knows from the indentation what commands are to be executed if the condition is met. Once we remove the indentation, the language interpreter considers this to be the end of the conditional statement and continues to execute the program. In our example, we check if the variable is greater than the number 10. If the condition is met, the contents of the variable will be printed. But what if we need to perform some action in case the condition is not met? For such a construct, Python has the else keyword. We simply add another block of commands. The else statement is again followed by a colon, which tells the interpreter that a block of statements will follow. When writing if and else statements, you need to be careful about all the indentation. Blocks of code must be indented from the if statement, but the else statement must be aligned exactly below the if statement. To make decision structures truly universal, Python also offers conditional statement extensions. A conditional statement allows you to insert several conditions that are evaluated one after the other. We replace the else command with another condition that precedes the ELIF command. We can insert as many conditions as we want, but remember the readability of the code. An else statement can also be placed at the end of an extended conditional statement. So what will happen? The first condition is evaluated. If it is true, the block of code below the if statement is executed. If the condition is not met, another evaluation is performed and so on. If none of the conditions are met, the block of code below the else statement is executed. And let's practice it. Let's have two numbers a and b. For simplicity of interpretation, both are of integer type. Let's try a simple test first. Is the number a smaller than the number b? We write the if statement with the appropriate condition. As soon as we press enter, the editor moves to a new line and, as you can see, automatically indents the next code. Any Python editor will do the same. On the next line, we write a simple print command that informs us that the condition has been met. Use the Shift and Enter key combination to run the code. As you can see, the condition was met and the program printed the information. Let's try it one more time but reverse the condition. We know that the number a is smaller, so the condition will evaluate to false. And as you can see, nothing happened, which we expected. Therefore, let's now try to add an else block. We run the code and got the result. This is how simple decision-making works in Python. Of course, we can test many conditions. I have prepared some examples and now we will try them. When we were talking about operators for numeric objects, we came across the modulus operator. As we said, this operator returns the remainder after floor division of two numbers. Let's first try how the operator works. We printed the remainders after floor division by 2. the interpreter returned the digits 0 and 1. What does this mean? If we divide any number by 2 with a remainder, it means that such number is odd. Otherwise, it is an even number. And so we can easily write a test for even and odd numbers. If the remainder after division is greater than 0, print that the number is odd. Otherwise, print that the number is even. We can try it for number b as well. Python also allows a short notation of the if command, in the event that only one command is to be executed after evaluating the condition. The first example shows a shortened condition without an else branch. In the second example, you can also see the else part and the notation is a little different. However, if we try to use such a construction without the else clause, the interpreter would throw an error because it is mandatory for this notation. Finally, the last example of abbreviated notation, which allows you to write even 3 conditions on one line of code. Of course, if commands can be nested within each other as desired, so let's show an example of a more complex evaluation. We have two numbers, 3 and 5. After starting, which number is larger is evaluated first. In the second level, we evaluate, for example, the data type. So for numbers 3 and 5, these lines of code are executed, as finally seen in the interpreter output. We can change the numbers so that the first condition does not apply, and in that case these parts of the code will be executed. If we are also testing the data type, let's change it to float. In this case, these lines of code will be executed. As you can see, information about float numbers has been printed. And why not try, for example, to change the numbers to a string data type? The interpreter did not return any output, simply because we don't test the type of the A and B objects to string and we haven't written the code to execute in that case. Sometimes we need an activity to be repeated. Python offers a while statement for such cases. Its construction is very similar to the if statement we showed a moment ago. The construction of the command is very simple. The entire loop begins with a while statement and, like an if statement, is followed by a condition and a colon. This is followed by an indented sequence of statements that will be executed as long as the condition is valid. That is, if the condition evaluates to Boolean true. Once the condition becomes invalid, the loop will exit and the interpreter will continue to the next statement. If the interpreter encountered a while statement whose condition would be false when initially evaluated, the loop would not be executed even once. I said that the while loop runs over and over until the condition is true. Nevertheless, a situation may arise when the process needs to be stopped regardless of whether the condition is met. There is a break command for such a case. Whenever we use it inside a loop, the interpreter immediately stops executing the loop and moves to the next statement. Most programming languages do not offer other options. But Python allows much more. As with the if statement, we can also define an else block for the while statement. It starts executing when the input condition becomes invalid. It doesn't matter if the condition was invalid the first time it was evaluated or became invalid during the execution of the loop. The last command with which we can influence the behavior of the cycle is the continue command. This statement terminates the execution of the sequence of statements inside the loop body and tries to evaluate the condition again. If met, the body of the loop will run again. Let's see how it works in practice.
Let's try a simple while loop.
we have a variable I that has a value of 1. The loop will repeat until the condition that the variable I is less than 10 is true. If this condition is true, the value of I is printed and the value is increment on the next line. Once the condition becomes false, that is, the value of I becomes 10, the code in the else section is executed. In the next example, we have a similar loop. As long as the value of the variable I is less than 10, its value is increased by 1. Then a test is made to see if the remainder after floor division is greater than 0, in other words, if the number is odd. If the number is odd, the continue statement is executed and loop execution returns to the first line. If the number is not odd, it is printed and the loop continues until the value of I is less than 10. As you can see, the program printed only even numbers. But why did it print the number 10 when the condition is that I must be less than 10? Look at the construction of the loop. This happened at the moment when the number I had the value 9. At that moment the condition was still valid. I was less than 10. On the 9th pass through the loop, on the first line of the loop body, I was incremented by 1, and only then was a test made to see if it was odd. So at the end of the loop, the variable I, which has a value of 10, is correctly printed. We can easily verify this by making a small modification to the code that will show us how the loop works. We will print out the loop pass number. And we will also print information about when the continue command was applied. So, as you can see at the end of the listing, on the 9th pass, the variable I had a value of 9 when the condition was evaluated, then it was incremented by 1, printed, and the whole loop ended. When modifying the code, I use two notations that look strange. The first is a call to the print function. Since you can't add string and integer objects, I had to help myself and first convert the number to text and then merge it with the second string. This is a bit clumsy notation. In future episodes, I'll show you more elegant ways to format the output. The second entry is also strange. I said that there can only be one statement in the body of the condition in the short notation of the if statement. But Python allows you to write several commands on one line if we separate them with a semicolon. This code notation is not pretty, but it can be used if absolutely necessary. Let's go back to the example one more time. This is how it looked before the modifications. Let's think about the order of the individual statements in the body of the loop. First, the variable I is increment, then the test is performed, and finally the variable is printed. But what if we swap the first two lines? What do you think? What will happen now? On the first pass through the loop, the variable I has the value 1. The test will evaluate to true because the remainder after floor division is equal to 1. At this point, the execution of the loop body code is interrupted and the interpreter tries to evaluate the while condition again. The condition is still valid, I is less than 10. And again and again. I show this example on purpose. By simply swapping two lines of code, we made an infinite loop. In this loop, the Python interpreter gets caught in the trap we just made. I ran the code a while ago, and as you can see, the simple and short code is still running. There is no choice but to stop it hard because it will never end on its own. But why am I showing code that I know is wrong? I'm showing it to you because in some cases such an infinite loop can come in handy. We can write it like this, for example. This loop will run for an infinite number of cycles and we can use it, for example, when we are trying to communicate with some remote data source that changes over time. Good manners in such a case include two things. First, we should define the place where, based on some condition, the loop should be terminated. Second, we should write a single line of code that tells the interpreter to stop for a while and let the computer handle other tasks. For this we will use the sleep function of the time module. In our case we will pause the execution of the loop for 2 seconds. I show this variant only for completeness. We will talk about modules and their use in the following episodes. The last statement for controlling the program execution that we will show now is the for loop. Unlike the while loop, the for loop runs exactly as many times as we want to repeat it. It does not evaluate conditions, but receives some set of values and runs for each value in the set exactly once. A loop begins with a for statement, followed by a loop expression, and finally a value source. Since this is a block statement, the colon and proper indentation of the loop statements must not be missing. The source of values can be any object that provides some set of data, or we can pass values by enumeration. The loop will do the following on each pass. It first takes the value from the source and assigns it to the loop expression. Then the sequence of statements in the body of the loop is executed. The entire process is repeated for each element of the loop source. Just like the while loop, in the for loop we can define an else block and control the loop's execution with the break and continue commands. If an else block is defined, it is finally executed once the value source is exhausted. With the break command, we can interrupt the execution at any time during the loop and move to the next command after the loop. The continue statement interrupts execution of the loop body, returns to the beginning of the loop, and attempts to execute the sequence of statements for the next value from the data source. The interpretation can be a bit confusing, especially if you have programming experience in other languages. It is best to show everything with examples. The simplest way to use a for loop, which perfectly shows how the loop works, is to pass the data source as an enumeration. If we are passing multiple values, we must separate each of them with a comma. In this first example, the data sources are the simple values 1, 2, and 3. The loop will run for each number and print its value. To demonstrate how the else block works, at the end of the loop, when there are no more input values left, information about the end of the loop is printed. The second example is similar, except that we use a range object to provide the data source. The range object will generate data from the number 1 inclusive to the number 3 exclusive. We can pass a third parameter to the range object, which specifies the step. So the next example will generate the sequence 1 to 9 with a step of 3. So that means the digits 1, 4, and 7. We can use any object as a data source. For example, the names of built-in functions or even data objects. If we go back to our first program, we can also pass a string object to the for loop. The loop then prints its value for each element of the object. In the case of the string object, the elements are individual letters. We can also nest the for loops into each other arbitrarily. In this example, we define two loops, x and y. The x loop runs 5 times, the y loop runs twice, and on each pass it prints a multiple of the numbers x and y. In the last example, we will show how the continue and break commands work. The loop goes through all the letters in the sentence "Hello World." But if it encounters the letter L, it stops executing the body of the loop and continues with the next letter. The moment it encounters a space character, it aborts the execution of the entire cycle. Therefore, the loop printed only the letters H, E, and O. We have only shown simple examples of for loops. Since this is one of the most used Python commands ever, we will try and practice it many more times in the following episodes. So that's all for today's episode. We explained how to control the running of a program in Python using loops and conditions, which can be considered the basic building blocks of any programming language. In the next part, we will show container data types and how to work with them. At the same time, we will practice working with loops on them. If you like the Python series for beginners, don't forget to subscribe and I'd appreciate a like too. I look forward to seeing you in the next episode.